Welcome back to In Ohio Country today. We're here at the Farm Science Review, actually at the Central State tent, one of our fine sponsors here on In Ohio Country today. And with me today is Luke Farno. He's working on a kind of a unique program, very unique program. So you want to tell us a little bit about that? Give us a little bit of background about yourself first, Luke.
Okay.
And then we'll get into the meat and potatoes of what we want to talk about here.
Sure. So I grew up here in Ohio, over in Eaton, Ohio. Went to school here, did my bachelor's work down at Eastern Kentucky University, then went and did my master's and PhD at Oklahoma State University. Have worked for several seed companies around the U.S., Gar Seed Company, Beck's Hybrids, those guys. And then have, over the years, finally came back to Ohio, and now I work at Central State University where I work with the corn breeding program with Dr. Mark Campbell.
Well, so that's kind of, corn breeding has been going on for centuries, and, to enhance the hybrids. And as a farmer, we're always trying to figure out how we could grow more bushels of corn, right? But you're focusing your research maybe a little bit differently.
Right. We're looking at something that is a naturally occurring mutation in the plant, and what results from it is an altered starch content. And so we have what they call high amylose corn. So it's not technically a GMO because we're not altering the genes. It's something that naturally occurs. So what happens with the starch is with normal starch, it gets very branchy like a tree, where with this, it becomes more of a straight line. And so when you look at it for food opportunities, the straight line kind of dissolves faster when you digest it. So for people with diabetes and that sort of thing, it's more of a slow release starch, sugar, that sort of thing, where normal cornstarch would just be like a boom punch. So they're looking at it in that aspects to work with diabetics for like things in breads, pastas, and that sort of thing. On the industry side, they're looking at it for uses in like 3D printing filament, use in computer chip development, the resins that they use for solar panels, and also biodegradable plastics.
Well, it's interesting. And always one of the questions producers are going to have, okay, so I plant this stuff, right? Am I going to have to not get as many bushels, or what's my production going to look like if I decide I want to raise this?
Right. Well, sometimes when you get into more of a food grade product, they always tend to yield less. Where this is a food grade product, but it still leans more towards the field corn aspect. So you're going to get comparable 160 bushel per acre yields. We're working on developing yields that are higher than that, but at least right now you're still in a kind of competitive area right now. So I know they did do some research, and they did find they could get 200 bushels per acre in some places when they were doing work in Missouri on it still. So there's a capability is there.
So if I'm, it's great that corn, we need corn for feeding livestock, and we need corn for ethanol. But what you're working on here is really just another value-added proposition for the producers in Ohio and other parts of the country.
Right, yeah. I mean, when we talked about all those different aspects that they're looking at, it's kind of the sky's the limit, because these are just baseline things that they're thinking of. So the possibilities are ever increasing with when they get into more of the research of the chemistry of the starch and what it can be used for. So now not only are you just growing a field of corn that could be used for feed or anything like that, now you're growing it where it could be used in industry for, like I said, 3D filament production and plastics, and food grade for diabetic consumption, that sort of thing. So it's giving you maybe the possibility of different niche markets that you can market your grain to.
So we talked before a little bit ago about that you're really kind of just really working on the inbred side, correct?
Correct, yeah. So if you see behind me, we've got these two different plants. The one right here on the left is an inbred plant. That's mainly what we work on. We work on these because we look for the gene that we're wanting, and then we look for good characteristics for like stay green, disease resistance, and that sort of thing. Once we see those, we start selfing the plants to lock those traits in. And then once we get into a group of inbreds that we like the traits that they have, we work on crossing those, and those are what become the hybrid, which is the plant on the right. It's exactly what your seed companies do, like Beck's and Garst and those guys. It's the same concept. So all of our work's in the inbred line development.
this is really a great program, and I'd like to take this opportunity to thank Central States for being a major sponsor here on In Ohio Country Today. And if somebody wanted to find out more information about this, where could they go?
If you go to the Central State website, centralstate.edu, and you go to the College of Engineering, Science, and Technology and Agriculture part of the website, there's a link, I believe, in there that goes to the corn breeding research. Or you can also go to the Extension website. I think there's some information there also.
Well, Luke, we appreciate you being with us today.
Oh, no problem. Thank you, and thanks for coming to the Farm Science Review.
We'll be back with more in Ohio Country Today right after this.